right, so a proportion is an equation where one fraction is equal to another fraction. And in order to solve proportions, we use what is called the cross product property. You might also hear this referred to as cross multiplying. Our proportions are going to take this form where we have one fraction equals another fraction. So I have A over B equals C over D. Then we cross multiply, and this is going to happen in an X-shaped pattern where I multiply A times D to get AD, and I can multiply B times C to get BC. So let's go ahead and look at example 1. I can multiply 4 times 7 to get 28. And then I'm going to stick an equal sign in the middle. And I'm going to do the same thing with 5 times x to get 5x. Now I'm going to solve this just like I would solve any other equation. So I'm going to draw my line through the middle and do inverse operations in the order of backwards GEMDAS, sad Meg, in order to solve for x. So I'll divide both sides by 5. And 28 over 5 doesn't give me a nice number, so it is totally fine if we leave our answer as the fraction. 28 over 5 equals x. Sometimes it gets a little bit trickier, and we start looking at fractions that have more than one term in their numerator or denominator. So 2n plus 4, there are 2 separate terms there. The rest of the problem pretty much starts out exactly the same. I can multiply 6 times 10 to get 60 and put an equal sign in the middle. But now when I multiply 5 times 2n plus 4, what I'm doing is I'm multiplying 5 to both the 2n and the 4. So I write it out like this as a reminder to myself that I need to distribute. I can drop down my 60. And this equals 10n plus 20. We want to make sure that we get both of those numbers multiplied by 5 and that we're not accidentally skipping anything important. From here, once again, this is just a matter of sad Meg. We are going to subtract 20 from both sides. And then I can divide both sides by 10 to get 4 equals n. Something in letter C would be very similar. Again, I am multiplying the 9 to both the p and the 10. So I'm going to write it out in parentheses to remind myself to distribute. And I'm multiplying the 8 to the p and the 7. So again, writing it in parentheses to remind myself to distribute. 9 times p is 9p. 9 times 10 is 90. 8 times p is 8p. 8 times 7 is 56. And now in order of inverse operations, I can subtract 8p to get my p's on the same side. That leaves me with just a p plus 90 equals 56. And I can finish it off by subtracting 90 from both sides to get that p equals negative 34. Go ahead and try out these next 3 examples.